Okay, so this is the quiz review for 1B, so the second half of chapter 1. This is going to quiz you on limits and rates of change. So the first part is using a graph to identify a limit. Make sure you are looking super carefully at where they're asking for the limit. So like this one is at 1, and then down here it's going to be at -1, because that's where you're going to be looking along your function in order to talk about the limit. So first they're asking for f of 1, which is just asking what is the value of the function when x equals 1. So here's 1. The place where we have a closed circle, like a filled in closed circle, is where we have a value of our function. So f of 1 equals -2. And then it's asking us about the limit. So first, on the left, it asks for the limit as x approaches 1 from a negative direction. So where is our function headed as it approaches 1 from a negative direction? And it's approaching that closed circle at -2. And then it asks us where our function's headed as x approaches 1 from a positive direction. So now we're going from here, as x is approaching 1 from a positive direction, we're headed toward that open circle, and this is toward +1. So because these are not the same, because as x approaches 1 from both sides, they are not the same, we say the limit does not exist. And then it's going to ask us about -1, so this is going to be right here. So it's asking us for the value of the function at -1. So we look for where there's a closed circle when x is -1, which is up here at +3. So the function exists when x is -1 and y is 3. And then it's going to ask us about the limit. So the limit as x approaches -1 from the left is at +2. And the limit as x approaches -1 from the right, from a positive direction, is also at +2 because it's heading toward +2. Because these are the same, we can say that the limit exists. Even though it's different from the value of the function at that point, the limit where the function is headed is the same. And so the limit is that value of 2. We'll do the same thing down here. Okay, we're talking about f of -4. So when x is -4, what is the value of my function? -2. Because we can see that the function is continuous through this point, we know that the limit is going to exist. So that's why you can check for that continuity first and look at the value of the function. And because it's continuous through that point, we know that the limit exists. But we can also see it because as x approaches -4 from the left, the value of the function is 2. And as x approaches -4 from the, not 2, -2. As x approaches -4 from the right, the value of the function is also -2. Because these were equal, that means the limit exists and it is -2. So then let's look at when x is 1. So we're talking about right here. The value of the function at 1 is way up here where we have this closed circle. So the value of the function at 1 where it exists, where it's a closed circle, is at +2. But then we're going to talk about the limit. The limit as x approaches 1 from the left is -2. The limit as x approaches 1 from the right is also -2. These are equal, and because they are equal, that is our limit. The limit exists, and it is -2. Next, we're going to use a table. So it is going to ask us a few things about the limit and about the value of the function at each. So first it's asking us for the value of the function at 3. This is going to be our direct substitution. So we're going to plug in 3, and we get 3 minus 3 over 3 squared minus 9, which gives us 0 over 0, which is most likely a whole in the function at this point. We can check that it's a whole by factoring. Top is already factored. The bottom is the difference of squares. And we can see that we would get a whole here by factoring. We can find the exact value of y at this whole, remember, by plugging in 3 into whatever is not part of the whole that we remove. So we'll see this in our table, but we can also check it because this, if we plugged in 3, we'd get 1 over 3 plus 3, which is 6. So we'll see if when we use our table, we get 1/6 for our limit, which is -1/6. not negative, it's positive, just positive 0.166 repeating. So let's check and see what happens. So when we plug in the value of f of 3, we got 0 over 0, meaning this is undefined or does not exist because we can't divide by 0. So we know that this does not exist. Actually, let's just write DNE. But we can look on either side to see if the limit exists. So let's start with the left-hand limit over on this side. And we're going to plug in values that get really close to 3 on either side of that whole, which doesn't exist, to figure out what the y value is. What is the limit? So this is where you're going to use your calculator. And then in y1, you're going to put, you're going to put the function. So you're going to put in y1, x minus 3 over x squared minus 9. And then you can hit graph if you want. You can see what the graph looks like. Remember, you can't see a hole on the graph. Then you quit. And then you're going to do your alpha F4, and you're going to say y1, put a parentheses. We want it to calculate when x is 2.99 in y1. And when we do that, we get 0.1669. And then if we get a little bit closer, do alpha F4, and let's do 2.999, which is 0.1667. Okay, so on the left, as the function gets closer and closer to 3, the limit is approaching 0.166 repeating, which is what we guessed it would be by doing our substitution, our algebraic method. So then let's look on the other side, on the right side, as we're getting closer and closer to 3. Let's do 3.01, which is a little farther out. So this gives us 0.1664. And then if we get even closer, we are at 3.001, 0.1666. So we are, again, on the right side, also approaching this value. So because these were the same, even though our limit didn't exist, or not our limit, even though our function didn't exist at this point, the limit exists because from both sides, it is heading toward that 1/6 or 0.166 repeating. Okay. Next one. F of x equals 4x over x minus 2. They are asking us for -2, which we can see is going to be a denominator issue. If we do direct substitution here, we get 4 times -2 over -2 plus 2, which is going to give us -8 over 0, which is not a function. It's not a definable function. So the function does not exist at -2. But we're going to look at what happens on either side of -2. This one we can't just plug in because we don't have a hole. So we actually have to use the table here in order to figure out where our limit is approaching. So we're going to put into our y1 4x over x plus 2. And then we're going to use our alpha F1 to calculate some values on either side of -2. So let's do a little bit bigger than -2. So -2.01 on the left. This is 804. And let's get even closer. Alpha F1, -2.001. And what you can see, if you kept going closer and closer, this is growing exponentially. Every 0 you put in is going to get you an even bigger number, meaning this limit to the left, as we are approaching -2 from the left, this limit is going to infinity. So this is going to end up looking like this on the left. So if this is -2, we've got this asymptote here. To the left, it's going to positive infinity. So let's look at what's happening on the right. So let's do -1.99, which is -796. Alpha F4, -1.999. -7996. This is the same thing. This number is getting exponentially smaller. So this side of our function is headed to negative infinity because these are not the same, right? Those are not the same. They do not equal one another. Our limit does not exist. So you have to recognize when that function is growing larger and larger really fast or smaller and smaller really fast, that it's headed to positive and negative infinity, because your calculator won't say negative infinity or positive infinity. You have to notice those numbers getting really big or really small. Okay, number 5 says find the limit at a given point using any method. So you can use your graph, you can calculate, like look at a graph on your calculator, you can plug in, you can use a table, you can use direct substitution. Okay, so for number 5, I'll start with direct substitution, because I should always start with direct substitution, which is going to give me 6 plus 1 over 6 minus 6, so 7 over 0. And I just have the 0 in the bottom. That means I have an asymptote. Typically, so I'm going to check my graph. I'll use my calculator, and I'm going to look at what's happening when x equals positive 6. So out here. So when I sketch this graph and when I look at my table, I can see that on the right side, so coming from the right, my graph is looking like this. I have an asymptote here. And my graph looks like this. It's coming from here and it's going to go up along that asymptote. From the left, it's coming from here and it's going to go down along that asymptote. So I would say, because the limit coming from the left is headed toward negative infinity, and the limit coming from the right is headed toward positive infinity, those are not the same. So my limit does not exist. And I could see that on graph. I could also see it if I had used a table. I would see that on the left side, values are getting infinitely smaller, and on the right side, values are getting infinitely bigger. Okay, so then number 6, let's start with direct substitution. If we plug in 2, we get 2 times 2 over 2 squared plus 3 times 2 minus 1. So 2 times 2 is 4 over 4 plus 6 minus 1. 4 over 4 plus 6 is 10 minus 1 is 9. Because we did not get any issue with our denominator, there's no domain problem here, this function exists and its limit is where it exists at 2. So that value of that function is 4 over 9. Okay, average rate of change over the given function. So we're going to start with 7 over the interval 0 to 4. Remember, this is our x1 and this is our x2. So we need to figure out y1 and y2. To find y1, we're going to plug in 0 here. 0 cubed plus 1 equals 1, so our y1 is 1. And then we'll plug in 4 to get our y2. So 4 to the third plus 1. 4 to the third is 16 times 3. I think it's 64. 64 plus 1 is 65. So 65 is our y2. Then we will plug this into our slope formula, y2 minus y1 over x2 minus x1. So y2 is 65 minus y1, which is 1, over x2, which is 4, minus 0. So 64 divided by 4, which is 16. So that is my average rate of change over this interval. Okay, then we'll do the same thing for number 8. This is my x1 and x2, and I need to figure out my y1 and y2. So when I plug in x1, I get negative 2 squared plus 2 times negative 2 minus 6. So negative 4 minus 4 minus 6. Negative 8 minus 6, so negative 14. That is our y1. Okay, and then y2, when I plug in positive 2, I get negative 4 plus 4 minus 6. Those cancel, which just leaves me with negative 6. So then I'll plug it in. Y2 minus y1 over x2 minus x1. So negative 6 minus negative 14 over x2, which is 2, minus x1. And then simplify everything. So negative 6 plus 14 over 2 plus 2, which gives me 14 minus 6, positive 8 over 4, which is 2. So there is my final answer. So that's what you can expect your quiz to look like.